Welcome back to Further Solutions Academy. Uh, we have been on series anyway, and before talking about opinions and other part of method, I think I need to explain what is called solution near regular and slash singular points. That is what I need to explain now, which is very, very important. Now, let me try to explain what is called regular and singular point. I think, let me try to explain in a very, very nice way. Now, if I have a point this, and I have, this is a neighbor, and I have, okay, this can be a city. Okay, let me just use Iwaya as a sample. Investor of Lagos. Now, Investor of Lagos, this is Investor of Lagos. Now, in that school, we have our boundary. Now, since I have this, now, and I will have the local government that the school is operating on. Okay, can you see? Now, listen to me very well. I will use this diagram to explain regular singular points. Now, this particular area, we call them neighborhood. Please take note of this. Neighborhood. Now, that is neighbor. Now, this particular part is called ordinary point. Please take note of that. Now, why this point is called singular points, which is my S naught. Please, that is called the S naught. The S naught. That is what you need to understand at this point. Now, don't forget, that is very, very important. That is very, very, very what? Important. Now, when you hear word regular singular point, you have to think in this direction. Very, very what? Important. Very, very important. Now, okay, now, with what I've explained, please take note of it very well. Very, very important. And there are 2 points. What is called ordinary points. And I've explained this is ordinary point, which you can see. Now, when is singular point, 2 things can occur here. Please take note of this. 2 things can occur here. Number 1, these are the 2 things. Number 1, we can see that regular singular points, most time they will put RSP. That is regular singular point. It means regular singular point can be occur here. It means that point is always there. It's always what? On the center. Hope you know that this point I can generate a lot of things there. You know, I can generate a lot of things there. And also, and I can say that irregular singular point also. Now we put ISP in regular singular points. They are all found around this place, neighborhood. You know, that is what I'm trying to explain here. Can you see what is called regular ordinary point? Okay, and you can see what is called regular singular point. Now, let me try to explain some, in a mathematical form. Let me try to show some questions on ordinary point and regular ordinary point. Now, okay, look at this problem. Okay, now let me explain with equation, which is if I have P of x, y prime prime plus Q of x y prime plus r of x of y equals to 0. Now, note, if p of x is not equals to 0, is what? Ordinary points. But if my p of x equals to what? Is 0, is called what? Singular. Singular points. Please, from my singular points, I can now say that me what? Is what? Regular singular points or irregular singular points. Please take note of this. Very, very important. That is what you need to understand at this point. That is what you need to understand at this point. Now, look at this particular problem. Look at this problem. I have this problem. Is x equals to 1 or x equals to 2 an ordinary point of x squared minus 4 y prime prime plus y equals to 0. Now, look at this. How do I solve this solution to this problem? Look at this. It's a very simple question they can ask you anywhere. Is this an ordinary point? The first thing I will need to do is that my p of x, note, my p of x, does it equals to 0? Is, let's try to see, is not equals to 0. You can see is not what? Equals to 0. I will now continue by saying that what? I can decide to divide everything by what? I think I'll be having y prime plus y divided by x squared minus 4 y equals to 0. X squared minus 4 equals to what? Is 0. Now, let's try to equate this to 0. It means my x squared equals to minus 4 can be equals to 0. It means my x squared equals to what? 4. My x squared equals to 4, which I have 2, which is, I'll be having, sorry, let me behave like mathematician, x 2, x plus 2. It means x equals to plus or minus 2. Now, x equals to plus or minus 2. Now, since I have my s equals to plus or minus 2, it means at s naught equals to 2. Take note of this particular. It means my p of what? 2. This is p of 2, which is p of 2 will now be equals to what? 2 squared minus 4 equals to 0. This is going to be what? 4 minus 4 equals to 0. Now, p of 2 equals to 0. P might equals to that. Now, since I have that, it means I have, you can see that y prime prime plus y all over what is 0 equals to what? What will it be? It will be what? Undefined. Which is going to be what? Undefined. Please take note of that. This particular one become undefined. Since I'm having undefined, it means I will be saying that what? At s naught, at s equals to 2, take note, at s equals to 2, p of s equals to 0, which is not an ordinary point. Does not have what? Ordinary. I think I've proved that does not what? Ordinary point, which is this statement is clearly proof. If it is not equals to 0, if it is not equals to 0, is an ordinary point. But if it's equals to 0, it is what? I think that is very, very clear. I have another question here, which is going to be of help. Okay, I think I have another problem here. I think I have. Okay, now look at this particular problem. Okay, I have another problem there. I have another problem here. Okay, let's try to see this. Maybe is what? Ordinary or what? Singular points. Don't forget, if it is singular, it will be what? Regular singular and what? Noun or irregular singular. Now look at this particular problem. I have x squared bracket of x minus 1 y prime prime minus 3xy prime minus 2y equals to what? Is 0. It's a very nice problem that I want to know whether is what. Now look at this. That is not equal to 0. It means my p of x is not equal to what? Is 0. Is not equal to 0. Now, since it's not equal to 0, it means is a what? Is a singular. It has a singular point, not ordinary. It has it is. Now it means I'll be having what? I can decide to have y prime prime minus 3xy y minus what? 2y. This is divided by what? X squared minus 1, and here will become x. I think I'm having 3x. Okay, this is going to be this will be 2y x minus 1 equals to 0. Now let's try to check something, whether it's what? Ordinary or not ordinary. Now look at this. Now my x squared bracket of x minus 1 is equals to 0. Now it means my x equals to what squared equals to 0, or x minus 1 equals to 0. Now it means I will now say that what? My x equals to what? 0 twice. It means what? Regular singular point. Take note of that. Regular singular point, because it is twice. It means that is repeated, not one, it's 2 and above. Now, but x minus 2, which is my x equals to, x equals to 1. I think you can see that. Why x my x equals to 1? Since my x equals to 1, it means is irregular singular point. Please take note of that. Irregular, because it's only one time. It's only one time. That is why we can say that what? That particular part is what? Regular singular point. And that 0 is 2 times. That is why it's what? Regular singular point. Please take note of this very well. I think that is how my lecturer taught me, my professor taught me then, and it was fine. I think I was fine with it. Now let me try to show another example. Okay, look at this problem. Let me try to work on this question. Now I have this question. My x squared minus 4 bracket of y prime prime minus x y prime plus 3y equals to 0. This is the problem number 1. I also move on to the problem number 2, which I have 1 minus x squared bracket of y prime prime plus 6xy prime minus 4y equals to 0. Problem number 2. And also I will have now I have x prime prime plus 4y prime plus y equals to 0. Now let's try to work along with this with better understanding. Now look at this. This is my p of x of y prime prime, and this is my q of x of y prime, and this is my r of x. Please take note of that. And they are very, very important. The stand is very important. The one attached to p prime prime, the y prime prime, is known as p of s. This one is known as what? Q of s, and r of what? Of x. Now the thing I need to do now is that my x squared minus 4 will it be equals to 0? Now it means my x equals to 4 equals to plus or minus 2. Please, my x equals to plus or minus 2. My x equals to what? Plus or minus 2. Now what am I saying? X equals to 2, x equals to minus 2. Now as it is so, this is called singular point. Singular what? Point. Singular point. Now look at this. I have the other one. I have okay, and I have 1 minus x squared. I'm looking at my conclusion with their own, so that I won't teach rubbish. I'm not yet a professor. Now this is equals to what? X minus squared equals to minus 1. My x equals to what? 1 squared, which is going to be what? Plus or minus 1. X equals to 1 or x equals to minus 1. X equals to 1, or x equals to what? Plus or minus 1. This is what? Singular point. Please, singular point. Singular point. Now, look at the third one. This one is very, very important. Take note of this very well. Now, I have something like this. The equation has no singular points. It has no singular point. That is just what? The value. Now, for instance, if I have something like this, x y prime prime plus x y prime plus x equals to 0. Now, it means my singular point will be equals to what? X equals to what? Is 0. Please take note of that. Take note of this very, very well. I think you have been fine. This is going to be what? Singular point and regular singular point. I'm looking at my write-up. I think it should be fine with this without no problem, without any issue. Now, I think yes, you can see what is called regular singular point, and you can see what is called ordinary point, and you can see what is called irregular singular point. Now, before I end this part of video, okay, let's work on this before I end this, because I have one very good example here that will explain all what I've been shouting on. For me, what I've been explaining since, I will explain it in a question that will explain it very well. Okay. Okay, look at this problem. I have a problem here which I need to present it on the board. Let's try to work on it. Now, I have this particular problem. X squared, bracket of x squared plus 1, x minus 1, y prime prime, plus 4x squared, x cubed, y prime, plus x plus 1, y equals to 0. Now, look at this. It's a very nice question. You want to check the nature of this differential equation. The first thing I will show, look at this. Okay, this is 4. From the question is 4. Now, can you see? Don't forget that the nature is what? P of x y prime prime plus q of x y prime plus r of x y equals to 0. Please, that is the nature of it. Why are we doing this? When we get to Frobenius, all this legendary, I think you will understand better. But try to understand what I'm trying to explain. Regular singular point and ordinary points. Please take note of that. Now, my P of x is equals to 4x4 bracket of x squared plus 1 and x minus 1. That is my P of x. Now, what make it to be equals to 0? Now, it will be equals to 0. Since it's equals to 0, I will now start by having x4 bracket of x1 bracket of x minus 1 equals to 0. Now, here, I'll be having x equals to 0 4 times. F-O-U-R, 4 times. Now, which I'll be having x equals to what? Plus or minus, I, plus or minus I, which is a complex, this is a complex problem. Now, and my x equals to 1. Please, if you don't understand this, you think you know that you can't be in this class. If you don't understand this, you can't be in this class. Just know that. Now, this is a complex, this is a normal, and this is 4 times. Now, listen to me. My x equals to what? Is 0. It means it's a what? Regular. And my x equals to I, plus or minus I, is what? Regular singular point. And my x equals to 1 is known as what? regular singular point. Now, hope you know that I can say that my s equals to minus I, f equals to I, they are both I, that is I, and my x equals to what? 1, which is what? Regular singular point. Now, this one is what? Irregular singular point, because it's being repeated. I think I need to stop here. I've done a lot of justification on this part of mathematics. I think this can be here for life, and you will enjoy yourself with mathematics. And don't forget mathematics. I must pass through mathematics. Now, with what I've done now, I think we have done a lot of justification to this. Yes, I think so. Just if in case you need our online class, call upon us. We'll be attend to you. And I'll be stopping here. Don't forget you are home with Further Solutions Academy. This course is under differential equation, and you can find it under the mathematical method, also, and it's not for elementary mathematics, advanced mathematics. Once again, thanks for watching.